6255 is a story problem, so if you haven't had a chance to go through and read it, please stop the video right now and read it. Basically, it explains what this picture is. This guy is standing on one side. He's got this boat that he can see, and in the description it tells you that this angle right here, x, due north is 0, to the left is negative, and to the right is positive. And the first question is, what's a reasonable domain? Well, obviously the ship can't go behind him in either direction. Once the boat comes over here, it can't go behind him again. And so straight across, which technically that really can't happen either, in either direction is a reasonable domain. And so that would be from negative pi over 2 to pi over 2. That's as much as we can get there. And then they want you to graph it on that domain. So I wrote the equation down here. D of x is just function notation for y. Remember that what we're actually graphing here is 1.5 cosine x. We're only going to go from negative pi over 2 to pi over 2. 1.5 is our value for a, so that means that we're going up 1.5. That's going to be our maximum value. Remember that the cosine graph would normally start at 0 and be at its maximum value, so it's going to start up there. These guys right here, the cosine would usually come down here like this and down here like this, which means these are x-intercepts, so those are going to be our vertical asymptotes. And then this is a maximum value, so this would be a parabola opening up. So that's what the graph would look like. They want to know, find and discuss for part C, any meanings of the vertical asymptotes. Well, we just talked about that. It's where it crosses on the x-axis graphically, and in the picture or in the real world, technically the boat can't get straight across from the guy since he's on that side of the shore, so it can't get across the lake or the river. Part D is to calculate, interpret d of negative pi over 3, round to the second decimal place. And so they just want to know what d is. Remember what this means. This means go find function d, there it is, replace the x value with negative pi over 3. Now, when we put secant in the calculator, remember we can't really put secant in the calculator. Secant does not equal that button on the calculator that looks like this. Instead, we're going to have to do 1.5 times 1 over the cosine of negative pi over 3. So when you put that in the calculator, the first thing you need to do is make sure, since we're in radians, that your calculator is in radian mode, which mine is. So I'm going to do the 1 divided by, so 1 divided by the cosine of negative pi divided by 3 first. Sorry about the glare there. We have a big window in our living room. And you're getting the skylights there too. So there is that. And then once I get that answer, I'm going to multiply that by 1.5. And I got 3. So this means that when this angle is negative, so it's going to the left, pi over 3, so when that angle is negative pi over 3, this distance of that boat is 3, what was that, in kilometers? 3 kilometers, it told us that in the story problem. E is going to be the same thing. D of pi over 6. So we're going to put 1.5 secant pi over 6. But again, we can't put that in the calculator, so we're going to do 1 over the cosine of pi over 6. So 1 divided by the cosine of pi over 6, and then times 1.5, and 2 decimal places, so 1.73. And again, that's in kilometers. And so again, it would mean now when the boat, after the boat passes by the dude, and this angle is now pi over 6, that distance is 1.73 kilometers. What's the minimum distance between the fisherman and the boat? Where does this occur? Well, the minimum distance is going to be when the boat's straight across from him. So when that angle, remember they told you due north was 0, so when that angle is 0 radians, that's when the distance is going to be the shortest. And so they want to know what the minimum distance is between that and the boat, and when does this occur. So when it's straight across from him, and then what we need to do is we need to calculate d of 0. So 1.5 times the secant of 0. So 1.5 times 1 over cosine of 0. Well, the cosine of 0 is 1. I mean, you can put all this in your calculator, but the cosine of 0 is 1. So you get 1 times 1.5, so 1.5 kilometers. Then the next question is also from 6-2. It is number 57, which again is a story problem. This one they did not give you a picture for. Make sure that if you need to, you go through and read the story problem now before we get done. But basically they want us to write a function expressing the altitude of the rocket above ground. And so they tell you that you have a video camera that's focused on a launching pad 2 miles away from the camera, and so this is the launching pad here. The camera is 2 miles away, and it tells us that the angle of elevation is pi over 120x after x seconds. So they want to know what is the altitude of the rocket. So this is the rocket taking off here. Ooh, rocket, ooh. And they want to know what the altitude is. And so we have opposite over adjacent. It's a right triangle, so we're going to use right triangle trig. Opposite over adjacent is going to be the tangent of the angle equals a over 2. And I'm thinking they probably, yep, they want us to solve that. So we're going to multiply both sides by 2. And they called this h of x. H, I'm assuming probably for the height, is why they named it h of x. And then for part B, that was part A, they want us to graph this on the interval from 0 to 60. And they don't want 0 or 60 included. This is a tangent graph. So the easiest way to do this is to plug in 0. And we would get tangent of 0, which is 0, which is 0. And then put in 60, which is pi over 2. Tangent of pi over 2 is not defined. And then, as we know, the tangent graph goes up like this. We don't do this side because we're not going beyond 0. So this is from 0 to 60. I changed that to pi over 2, but it should be 60 technically. Okay. Evaluate and interpret the values of h of 0 and h of 30. Well, we just did h of 0. So 2 tangent pi over 120 times 0. So you'd multiply here and you'd get 2 times the tangent of 0. The tangent of 0 is 0. 2 times 0 is 0. And then h of 30 is 2 times the tangent of pi over 120 times 30. Pi over 120 is pi over 4. The tangent of pi over 4 is 1. Memorize those tangent values. Times 2 is 2. They want you to interpret these. So this means at time 0, the overall height is 0. This means at time 30, and 30 is in seconds, so after 30 seconds, the height is 2, and the height is in miles. So that means that's the interpreting after you evaluate. What happens to the values? Part D, as x approaches 60 seconds, interpret the meaning. So this is where 60 seconds is at. That's the vertical asymptote. It can never reach there. Basically what's happening is this is the height of the rocket as we're going along time. It increases very, very quickly, and it tries to keep increasing, but eventually it can no longer increase anymore. That distance becomes unmeasurable as it gets away from Earth. And so that is what happens. As it approaches 60 seconds, once it gets to 60 seconds, it's as high as it can go for this problem.